Welcome back to another exciting quadratic class year 11. We're going to be looking at quadratic identities today, so let's get into it. Now, if two quadratic expressions are equivalent to each other, then the corresponding coefficients must be equal. So let's have a look at what this is saying. If I have, first of all, let's actually look at this. If I have this sign here, that's equivalence. That means that they are identically equal to. We've used that sign when we were talking about identical shapes, when we were talking about congruence. We can use it when we're talking about equations that match up perfectly. So if I actually told you that, say, 2x squared plus 5x plus 7 was identical to ax squared plus 5x plus 7, you could look at that and go, well, it looks fairly straightforward and obvious that a would equal 2. Regardless of the values of x. When I look at this particular question, it doesn't matter what x is, these equations are always equal to each other. So that's what we're actually doing with this sort of topic. We're going to be equating things. So let's have a look at our examples. The first one says, write 3x squared, take 4x, take 10 in this form, bracketed form. Oh. Okay, well, we're told that we're going to write in that form, which means that we're going to assume that they are the same. So let's actually look at this. We'll go 3x squared minus 4x minus 10 is identically the same or equivalent to this form, because we're told that we can write it in that form, and we're told to write it in that form. Well, if they're equal, let's go over to the right-hand side of our statement. Actually, I'll write this again. On the right-hand side, I'm going to get, well, let's just be careful here. When I expand this bracket here, x take 1 in bracket squared, I'm going to get x squared minus 2x plus 1. That's smiley face, or expanding the bracket out. But I'm also going to times every term by a. So I know I get an x squared, so I'll get ax squared minus 2x, so I'll get minus 2ax plus 1. So I'm going to get plus 1a. So I've times a to all of the answers, plus. Now I'm going to multiply this b into this bracket. So I'll get plus b, x minus b plus c. Now this next step's not required, but it makes it a bit easier to see. What I'm going to do is write any term that has x squared first. Any term that has x, I'm going to write next. Oops, missed an x there for some reason. And I'll write the constant terms, the ones that don't have x, last. Again, you don't have to do this step that I'm doing now, because what we're going to do is we're going to equate things. So let's write this down. Equating x squared. Now what does equating x squared mean? Well, it means that because I know these two equations are identical, whatever's in front of x squared on the left side is equal to whatever's in front of x squared on the right side, which means I get 3 equals a. And if I'm looking at the x squareds, I can just write down that straight away. I know capital A is now 3. I'm also going to look at the equations, and I'm going to equate x. So looking on the left side, I've got in front of the x, there's a minus 4. Looking on the right side, in front of the x's, there's a minus 2a, but there's also a plus b because there's more than one x term. So I need to factor that into my working here. So on the left side in front of x is a minus 4. On the right side, I've got a minus 2a and a plus b in front of my x terms. But I know what a is. A is 3. which means I now get minus 4 equals minus 2 times 3 plus b, following this through, plus 6 to both sides, and you'll get b equals 2. And the last thing I need to equate, now I could call them constants, but I abbreviate it like this. That just means equating any term that has no x's. So on the left side, I've got a minus 10. On the right side, I've got a couple of letters. So I get minus 10 equals a minus b plus c. But I know what a is, and I know what b is, so I know these two values. So I get minus 10 equals 3 take 2 plus c. 3 take 2 is 1. When I subtract that across to the other side, I end up with c equals minus 11. So the final answer, well, the final answer is, I've got to write it in the form, is this. 3x squared minus 4x minus 10 is exactly the same as, instead of writing a, I'm going to write 3. So I write 3 bracket x take 1 close brackets squared plus, instead of writing a b, I'm going to write 2 bracket x take 1. Instead of writing a plus c on the end, I write minus 11. That is your solution. I've written the quadratic in the form it asked me to. Let's try example 2. We'll start by rewriting the question with the expansion. So x squared minus x is exactly the same as, now when I expand x plus 2 in brackets squared, I get this. X plus 2 in brackets squared gives x squared plus 4x plus 4. But everyone's going to be timesed by a. So I need to be careful when I'm doing that. I need to multiply everything by a. So let's go back, get rid of that. And you get x squared. It'll be ax squared plus 4x plus 4, so it'll be plus 4a plus bx plus c plus 4. So let's go and equate x squared on both sides. That means we're matching up what's in front of x squared on this side, what's in front of the x squareds on this side. Well, you can see on the left side there's 1x squared, on the right side there's ax squared, so a equals 1. Let's equate the x terms. What's in front of x on the left side? Well, in front of the x is a minus 1, and on the right side there's a 4a as well as a plus b. So we get 4, whoops, I don't want to write down the left hand side first, minus 1 equals 4a plus b. But we know what a is. We know a is 1. So it becomes 4 lots of 1 plus b. 4 lots of 1 is 4, minus 4 to both sides, and you get b equals minus 5. Now we're going to equate or match up the constant terms, the terms that have no x's. Well, on the left side of the equation, there are no terms that have no x's, so there's 0 on the left side. On the right side, the terms that don't have x are the 4a, the c, and the 4. So we get 4a plus c plus 4. But we know that b is minus 5 and a is 1. Well, we don't need the b, but we can use the a, which will give me 4 lots of 1, or just 4. That 4 and that 4 will add to give me 8. Take away 8 to both sides. So, find the values for a, b, and c. A is 1, b is minus 5, and c is minus 8, and they are the values that we were asked to look for. Now with example 3, we're actually not going to do it. So we can leave example 3 off because it's not really strictly related to equating coefficients nicely, and goes on to solving triple simultaneous equations, and we won't be testing you on any of that. So let's skip this particular question. That's it. Time to get into it. And if you do get any triple simultaneous ones, don't worry too much about those. Bye for now.